Hello, we are continuing on this software-defined radio with RTL SDR on Module 3, SDR Advanced features. Here we are going to see how to cancel the frequency offsets and other bias. We have done this block based on a Simulink example that you can execute because it's included in the MATLAB package. Here, this example is doing a DC offset cancellation, frequency offset cancellation, and also show us how to do many mathematical operations with signals, and also how to use MATLAB code and other examples of processing. This is the block diagram for offset calibration. It has the RTL SDR with the frequency input, and here we have one block called receiver. Then there are two displays, one for the frequency offset and another one for the frequency offset in parts per million. This value is the value that we can input in the SDR to cancel the frequency offsets of the internal clock. These frequency offsets are important to have an exact frequency accuracy. The receiver, it has two blocks inside. The first block is to remove the mean value of the signal. This software-defined radio used to give a DC component in the central frequency. This is due to the internal processing circuits, and we can remove these components at zero frequency with an element called remove mean. And also we can find the peak frequency to obtain the frequency variation and to see the internal clock correction of frequency. The block remove mean, it makes the mean value calculation and then obtains this mean value and rests this mean value to the signal. Then at the output it's remove it. It uses these blocks and it has this parameter that gives the mean value of the signal, and then we rest this value from the original signal. It's very simple. Then the find peak frequency, in the other hand, is quite complex. It finds the index of the maximum amplitude across the frequency band and convert this index to a frequency offset. It has a probe block, a periodogram block, and this block, which is a block to execute MATLAB code. Inside here we have a MATLAB code. The example is complex, but it's very useful in many other circuits to obtain the peak value of a frequency, to obtain the center frequency of a signal, or many other case. This is the MATLAB code inside find peak frequency. Okay, you can see that it's using the FFT and it's doing some process with the sample time. And this is an example how you can mix Simulink and MATLAB code. So we can add any code here, and using this box we can put the MATLAB code. Okay. So let's see how it's working the example. For this example we are going again to use a remote control as transmitter. This remote control transmits in the frequency of 433.92 MHz. So we use at this control is very stable, so we can use at a transmitter. We switch now to Simulink, and we are going to see how is working the example. We execute the example, and here we have put the expected center frequency, which is the frequency of the remote control, and we'll see the spectrum in the different points. Well, first of all, we can see here the spectrum before and after the remove mean circuit. We can see there is a peak value in the zero frequency, which is the DC component, and here it has been removed. Okay, this is done inside the receiver with the remove mean circuit. Now we are going to transmit a signal, and we will see this is the received signal, and here we obtain the frequency offsets in part per million. This is 34.88. You can see this is the transmitter, and we are obtaining the peak of the transmitter and measuring this frequency shift. Of course, you can do this by hand, but here we show you how to do it automatically. So we stop the RTL and we put the frequency shift here in the RTL. We put here 33.88. Okay, you have to put an integer value. We execute again, and now we can see how the transmitted frequency is in the center and the frequency offset is nearly zero. It's a discontinuous transmission, so it's changing sometimes, but we can see the frequency offset is very small, less than 1 to 3 parts per million. Okay. So, thank you very much for your attention, and that's all for today.